Okay, I'm going to do Chapter 9, Problem 39 on the Physics C homework. A rod of length 30 centimeters has a linear density, mass per length, given by lambda equaling 50 grams per meter plus 20 x grams per meter, where x is the distance from one end measured in meters. So A, what is the mass of the rod, and B, how far from x the x equals 0 end is the center of mass. So first, what we want to find out is, well, first I'm going to draw a picture of the rod. And so here's when x equals 0. This end, the rod is 30 centimeters. So here is when x equals 30. First, what I did is I graphed the lambda equation over centimeters. And if you notice, the area under this curve is actually the mass of the rod. So to find the area under the curve is just the integral, and that's basically what I did. So first we have the integral of dm. So for every small mass we have, just add them all up. But since we don't have an equation or any of the units for that, we have to use the density or lambda equation. So that's lambda equals dm divided by dx, dx being distance. And so then dm equals lambda dx. And we can use lambda dx, replace over here, and since we do know the distance, we can put those in. So from 0 to x, and x in this case is 0.3 meters or 30 centimeters. And then from there we just plug in what lambda equals, take the antiderivative of that, calculate that for when x equals 0.3 and when 0. Calculate that out, this will become 0, this calculates out to 15.9 grams. So that is the total mass of the rod. Part B asks for where is the center of mass, and for that you want to find where the left side of the rod equals the right side. And so where is that? Where do you split the rod? So from 0 to that point, that's center of mass. Take that lambda multiplied by dx, that change in distance, and that needs to be equal to the right hand side where you start from that length before, go all the way to the end, and where does that where do these two equal each other? So when you calculate these out, you have you just will calculate this out. You have 50 times L plus 10L squared minus 50 times 0 plus 10 times 0 squared. So this part goes away. And then you solve that from here. This again is like the total mass of the rod, so that's 15.9. And then we're subtracting this. This side will equal this side, so you get twice here. And you get a quadratic equation at the end. We said that equals 0. I graphed it, found where I found the where it passes when x equals 0, that's at over y equals 0, but that is at 0.1542 meters or 15.4 centimeters, and then that is the center of mass because it's more towards the right side because the right side is more massive than the left, so that is the center of mass.